All right. Hi, folks. My name is Robert. I'm here to talk about Isograph. Isograph is a framework for building React apps that are powered by GraphQL data. It has ambitions to be a framework for building apps that are powered by data, but all in due time. The project has many goals, but I think the primary goal is to drastically improve the developer experience of building world-class data-driven apps that are performant out of the box. It's very much a work in progress, but it's in use in actual projects, and so far the reviews are stellar, and I hope you give it a try. So on the subject of how to improve performance, I was scrolling my feed recently, move my mouse out of the way, it's in the wrong place, and I came across something that really spoke to me. Something along the lines of, if you improve performance by 20%, you might have started doing something clever. If you improved it by 500x, you stop doing something stupid. And that speaks to the way that I think about Isograph. Isograph will achieve the goal of having you stop doing wasteful things when building apps and at runtime by not doing unnecessary works. And that's why I call this presentation doing the bare minimum with Isograph. We're going to do the absolute bare minimum of things that get in the way of writing performant apps. So coordinating and making sure that something isn't broken, enforcing invariants, things like that. Instead, relying upon the Isograph compiler to do all of the dirty work. And at runtime, our apps will be snappier, not because we found some fancy new diffing algorithm, but because our components will re-render only when data actually changes, we'll fetch only the data in JavaScript that we actually use, and we'll split up network requests for better performance. In other words, we'll do the absolute bare minimum of things that don't matter, while also still providing a great user experience. Okay, so Isograph aims to help you efficiently build performant, data-driven apps. This is not every project. If you're just building a static marketing page, or you don't care about performance, or you have all the time in the world to optimize every little detail, then maybe you don't need Isograph. But if you want data-driven features, oh, this is not moving? Yeah, but if you want data-driven features, great performance, and developer velocity, then Isograph is for you. Okay, so if I'm going to claim that Isograph vastly simplifies the process of building world-class data-driven apps, then I really should substantiate the assertion that building data-driven apps is really hard. So let's talk at a high level about how we can build a screen in an app. So no need to look at this page closely. Just know that there's an outer component with a bunch of subcomponents. Now, we could have each subcomponent fetch its own data, perhaps in a use effect. So what happens when this screen is rendered? Well, React will render the outermost component, kicking off a network request and showing a fallback. When that completes, it'll kick off a network request for each of the subcomponents, and the content will pop in whatever random order the network requests complete. Eventually, the full component is rendered. Now, I think we can all agree that that's a lot of loading states to show to the user. And even for such a simple app. But nonetheless, many apps are still built this way. But there are three more subtle reasons why this is a bad user experience. First, it's slow. We don't kick off the network request for the subcomponents until the outer component's network request entirely completes. Second, every component is only concerned about fetching its own data, so there's no deduplication of fields, so we're hitting our backend more than we otherwise need to. And third, the choice of what loading states to show to the user is dictated by how we broke apart the component into subcomponents rather than what's best for the user experience. Okay, so this architecture clearly pretty bad. How about we do the obvious thing and just make a single network request for all the data needed by a given page. The root component fetches all the data, we pass it down, and then, yeah, now we're getting somewhere. There's a single loading state, there's implicit deduplication of fields, and the data is fetched in one pass. It's kind of a nice user experience. But now, imagine you haven't looked at that screen for a couple months. You come back from pat leave and all the interns have made changes left and right. You don't know how everything works. And you receive a ticket from your product owner to remove a field from some subcomponent. Okay, that part's to stop using the field. Okay, that part's easy. You stop using that field in that subcomponent. And like a good citizen, you go back to the query declaration, you prepare to remove that field. Can you? Oh no. Not without first doing a whole bunch of research and finding out where does that data actually flow. And what if a subcomponent is using it through JSON.stringify or object.keys? Or what if somebody lands a change at the same time that starts to use that field? This problem is even worse if that component is used across multiple screens. Now, we engineers, we think of ourselves as the pinnacles of rationality. We reason through things and win every argument, and we respond to incentives. So in this situation, we think, if I remove that field from that query, I can make the app slightly faster, but I risk breaking production. So we know how that plays out. The fields don't get removed. Queries become bloated, filled with fields that are probably unused, but which no one is brave enough or frankly stupid enough to try to remove. If that's a bit abstract, think about what it's like when we manually wrote CSS files. It's hard to prove that a given selector is not used by any subcomponent, especially as the app evolves over time. So our CSS files ended up bloated, filled with a bunch of zombie classes, selectors, and styles that are probably unused, but nobody's sure enough to remove. So the problem in both of these situations is that there's an implicit, not explicit, dependency between the query declaration or CSS file and its subcomponents. So what can we do? Well, going back to data fetching, both of these approaches have trade-offs. On the one hand, combining all the data dependencies into a single request results in better performance with fewer loading states and a better user experience. On the other hand, if every component fetches its own data, it becomes really easy to ship changes. We just have to reason locally, make whatever changes we need to, we can ship, and production never breaks. So let's unpack that last one a little bit. Well, it doesn't actually matter where the network request is made, as long as each component declares its own data dependencies. So is it possible to have each component declare its own data dependencies and a single query fetch all the data for a given page? Yes, that's the killer feature of GraphQL, and y'all are at the right meetup. In GraphQL, each component uses a fragment to specify the data it needs, and at compile time, that gets turned into a single query that fetches all the data for a given page. That's great. Okay, so now let's get back to talking about how hard it is to write performant apps. Or I should amend that slightly. Clearly, it's easy to write a single query when initially creating the app. It's hard to amend that query and maintain that performance profile as the requirements change. We just saw how adding or removing a field from a subcomponent will require you to add or remove that field from a query. And determining whether to do so requires global knowledge of all the other components on the page and what fields they actually use. But that's not it. If you selected a field and added it to a query for that screen, that may not be enough. You may also need to find out whether there are any refetch queries or pagination queries that also fetch the data for that subcomponent. And what if the subcomponent is used across multiple screens? Again, the problem is not as trivial as it sounds. And did you know that if you start using the field in a subcomponent, the proper optimal response may be to actually remove it from another query? I know that sounds bonkers, but hear me out. Imagine you're showing a popover for a given page, which has its own associated query. The request for the popover's data doesn't need to contain any fields already fetched by the page's query. So adding a field to a subcomponent on the page may require you to remove that field from the popover's query. Or imagine you have a primary query that fetches the data used by the above the fold components, such as a blog header, and a secondary query that for the fields used by the below the fold components, such as a blog body. In that case, if you add the field to the header, the optimal remove is to remove that field from the query for the blog body. Or what if you're navigating from one page to another? If a field has already been fetched on page 1 and we know that statically, then why do we need to fetch it when we go to page 2? Okay, so if all that sounds like overkill, well, in many cases, yeah, it might be. But if you're building an app with millions of daily active users, little improvements in performance add up to millions of dollars. And if that sounds impractical, like that'll never work in real life, a little bit of overfetching is better than wasting precious developer time, like removing some field from a query, whatever. None of it's practical, yeah, if you do it by hand. But once we have a compiler that does all the work for us, well, it doesn't sound so unreasonable after all. Again, let's get back to CSS. How much easier is it to have optimized CSS if we use Tailwind, which generates the CSS file using a compiler? I wouldn't handcraft that CSS, but now that we have that awesome build tool, it's basically malpractice not to use something like that. Okay, so the only way this will be worth the effort is if all the queries are calculated deterministically written by a compiler. So, taking a step back, let's talk trade-offs. If we're manually writing queries, we're either sacrificing performance or stability. We sacrifice performance by being conservative and overfetching, or we sacrifice stability by being aggressive and potentially not fetching enough data in some circumstance and having a broken app. Or we have to carefully check the queries on every deploy, sacrificing developer velocity. Again, performance, stability, and developer velocity. Isograph lets you choose all three. Okay, now GraphQL can't handle everything I described above, but it gets us pretty damn close. So let's talk about why, when you write an Isograph app, you're not actually writing GraphQL. I swear, this is the last tangent that I'm going to go on before we actually talk about what Isograph is. Let's talk about something quite common. Let's talk about breaking apart a component with a single fragment into a parent component with a child component, each with its own fragment. Well, I have to decide upon a globally unique fragment name for the child component. Why do I have to do that? The name I give it doesn't have any material effect on the app's behavior. Why do I have to pick one? Why give ourselves multiple opportunities to make a typo? Likewise, I have to decide on a name for the fragment reference prop. The name of the fragment reference prop has no effect on the final app's behavior. That's another unneeded step and another opportunity to make a typo. In the child component, there's nothing we can do with the fragment reference except to read it. Why is that a separate step? Why isn't it done for us? And why do we have the possibility of passing the fragment reference to any other subcomponent? Oh, sorry. In the parent component, why do we have to spread the child fragment and import the JavaScript for the child component and pass the fragment reference to the child? If I'm not doing all three, my app is necessarily broken. Can these be combined? And why do we have the possibility of passing the fragment reference to any other subcomponent? Only one component is capable of reading that fragment reference. If we pass it anywhere else, our app is necessarily broken. Now, if you've been doing GraphQL for a while, all this is second nature, but put yourselves in the shoes of somebody who's introducing GraphQL to a new code base, or teaching people, or somebody who's just new to GraphQL. Adds up. So that leads me to ask, why? Well, the answer is obvious. GraphQL was designed back in the day. We didn't know best practices, and change is slow. But there's actually a deeper, more insightful reason here. It's that GraphQL was designed as a query language for APIs, but we're hijacking it and using it as a way to provide data isolation to our front-end components. So it's natural that certain insights that are specific to the front end are missed. For example, we never took seriously the fact that each fragment is only ever read out by a single function or component. That may be surprising, but it's true. The blog post header component reads the blog post header underscore blog post fragment. Nobody else does. And that's how we get data masking. To the outside world, a fragment reference is an opaque object, but one specific component has the superpower to unmask that fragment reference and read out that data. And data masking, it's a killer feature of GraphQL on the front end. It's what makes apps built with, say, Relay or Isograph so much more stable than apps built in any other way. And if we lose all that, well, something's gone horribly wrong. So let's make sure we maintain data masking. And all that boilerplate I listed beforehand, the globally unique fragment names, the passing of fragment references as props, and reading and so on, that all goes away if we just know that only the blog post header is ever going to read the blog post fragment. And that's Isograph. Isograph is an entire framework built upon that idea. Okay, so let's see how far that takes us, and finally talk about Isograph. In Isograph, developers define components along with the data that they end up using. So consider this blog post header defined with this ISO function. It selects the title and author, which are GraphQL server fields. These then get passed in as part of that first parameter to this function. Well, what do we do in that function? Well, we're defining a component, so let's return some JSX. Now, today, I'm going to be using the term client field a lot. A client field is a function from some graph data to an arbitrary value, defined with this ISO function. That blog post header, that's a client field. The important thing to note about client fields is that they can depend on each other. So if we take a step back, we can take a look at this blog post body. This is another client field. It selects the blog post header and blog post body. These get passed in as part of the first parameter. And what do we do in that function? Well, those are components, right? So let's just render them. That's the developer experience that Isograph provides, and it's real, honest to goodness, functioning Isograph code. So let's talk about what stuff we didn't do. The blog post header didn't care how it got the title and author, how they were originally fetched. It just received them. When we wrote the blog post display, we didn't explicitly import the blog post header and body, we just received them. And furthermore, the blog post display didn't pass down any data to the blog post header. In fact, the outer component didn't see or have access to the fields that the child component used. That's great. That means we can make changes to client fields with impunity because the behavior of no other component is going to change. And another thing that we didn't do is explicitly type anything. And yet, that first parameter is fully statically typed. Now, we're writing components here, and components take props. How do we handle that? Well, we do that by giving these components a second parameter. And now, wherever we render the blog post header, we're going to start seeing a type error because we didn't provide this newly required on-click prop. Now, how does this work? Well, while we make those changes, we're also running the Isograph compiler. Whenever you save a file, the Isograph compiler will scan your code base for these Isograph literals and generate a bunch of files. If you make a mistake, the Isograph compiler will helpfully print out some error message indicating exactly what went wrong. Now, if the Isograph compiler encounters a so-called entry point, which is how we tell the compiler that a given fragment is essentially a query, one of those generated files will contain the query text that is sent to the backend. This query text will contain exactly the server fields that are used by any client field reachable from that entry point. So this means that if we modify a client field to stop selecting a given server field, it will be removed from the query text if and only if no other client field is reading that field. Once again, we can make changes with impunity and be assured that the query that we're sending to the backend contains exactly the needed fields, no more and no less. Now, we're building a data-driven app, so let's go ahead and use that entry point to make a network request. First, we'll pass that entry point to use lazy reference. This is a hook that when initially rendered will make a network request for the query text. It gives us back a fragment reference, and we can read the results of that network request by passing that fragment reference to use result. Now, use result will suspend while that network request is in flight, and when that network request completes, it will tell React to re-render that component. When we re-render that component, we get the blog list and we render that. The blog list renders the blog post display, which renders the blog post header, and so on and so forth, and thus the entire app is rendered. If you understood that, you understood the gist of how Isograph works. But I can see it in your faces. That's not enough. It's 2024, and it's not enough for apps to load initial data. They need to paginate. They need to refresh. They need to load data when the user clicks on something. And not to mention, what happened to loading just the JavaScript that we end up needing? And sometimes for performance reasons, we need to break apart a query into a high priority and fast part and a low priority slow part. Well, would you believe me if I told you that all of that was powered by a single building block? Yes, you heard that right. Pagination, loading data in response to events, loading just the data you end up using, splitting queries up into parts. That's all powered by a single feature. And that feature is loadable fields. A loadable field is like an entry point embedded in another query, and it's a fundamental Isograph concept. Let's take a look at that blog post display component again. We really want to display the blog post header as soon as possible, but the blog post body contains some fields that are slow to calculate, and we're okay with loading it a little bit later. Well, one way we can do that is by annotating the selection with @loadable. Now the parent query will not include the data for the blog post body, and instead of receiving the component directly, what we're going to receive is a function that, when called, will make a network request for the fields needed by that blog post body. We can pass this so-called loadable field to use client-side defer, which, when initially rendered, will make a network request and give us back a fragment reference. And like last time, we can pass that to use result to read the results of that secondary network request. However, this will cause the entire component to suspend, meaning that we won't render the header until after the blog post body network request completes, sort of defeating the purpose. So this time around, we're going to pass it to fragment reader, which is a wrapper around use result, and wrap that in a suspense boundary. Now, when this component initially renders, we kick off a network request, we show a suspense fallback, and when that network request completes, we replace that suspense fallback with the blog post body. And if this sounds like the defer directive, that's exactly right. This is defer, but with strictly worse performance, because we're kicking off a network request during render. But the point is this, Isograph has your back. If you don't have a server with the latest and greatest in bells and whistles, I know you don't know what that's like, Benny, but it's a real thing in real companies. Isograph will help you use the more performant pattern now, and when you're ready, it will give you a smooth upgrade path to use the better performing pattern. Okay, so for asynchronously loading the data for the blog post body, isn't it a best practice to asynchronously load the JavaScript for that component as well? We don't need it for initial render, right? Well, In every other framework, there's no connection known at compile time between the data that a component uses and its JavaScript. So it's always going to be a separate step to asynchronously load that JavaScript. So easy to miss, easy to make a mistake, no static enforcement. But Isograph makes that easy. With just a minor tweak, now when this component initially renders, we'll make a network request for the JavaScript for that component and for that data. And if this reminds you of relay entry points, that's exactly right. This is relay entry points requiring no server support, doable now in userland with loadable fields. And just as a note, this is only possible because we didn't require the JavaScript for the blog post body ourselves. Instead, it was provided to us as part of that second parameter. And the Isograph compiler is smart enough to know that when it encounters this, to replace that hard require with an asynchronous import for the actual JavaScript. Okay, so what else can we do with loadable fields? Well, what if we call it in a set interval? Hey, that's like a live query, doable now in userland with loadable fields. And what if we call a loadable field multiple times, passing in different parameters and concatenate the results? Hey, that's pagination, doable now in userland with loadable fields. Isograph ships with a skip limit pagination hook and a relay style pagination hook. But what if that's not right for you? What if you want to be able to fetch, do reverse pagination, refetch individual segments, fetch pages that you haven't reached yet, or you want to do Reddit style threading, whatever? Well, it's all implemented in userland, so you can add whatever features you need. It's not exactly trivial. There's some bookkeeping to ensure that there's no memory leaks, but you can do it. And furthermore, there's no magic involved in integrating with a router. So if you want to keep a hash map of loadable fields or entry points, then by all means, go for it. You can model your state using whatever data type is appropriate for your situation. Okay, so let's talk about the final boss for every web platform team. There's a fundamental trade-off between letting developers add features and shipping a small bundle. So let's talk about loading just the JavaScript that we end up using. Let's imagine we have a news feed with not just text, image and video posts, but events, songs, albums, fundraisers, and more. Not to mention 50 different variations you'll only see if you're part of some A/B test. It's incredibly wasteful to send all that JavaScript to every user because they won't see every type of newsfeed item. And it's an incredible disincentive to experiment if adding a new variation bloats the bundle for all your other users. Okay, so loading just the JavaScript for the types of objects that you actually encounter, well, that's really 3D. And that's the superpower that allowed Facebook to make the newsfeed load so quickly, and you guessed it, it's doable now in userland with loadable fields. Now, I don't want to pretend it's all sunshine and rainbows. Isograph's a work in progress. There are unimplemented features. But the point is this, none of this requires server support, none of this was possible a year ago, and we're shipping features faster than ever before. And everything we need, it's on the roadmap. Okay, with that caveat aside, let's finally prove that Isograph is not vaporware and look at a real, honest-to-goodness Isograph app, the Lorem Ipsum blog. Okay, so let's take a look at what happens. Actually, I'll show the actual thing first. So this is the news feed here. First thing you'll notice is that as you paginate, we'll get this GraphQL request, and when we first encounter an ad, which was part of this GraphQL request, actually, let me just refresh this real quick. First pagination, we don't encounter an ad. Oh, I guess we do, because it depends on the screen size. So this is the first time we've encountered an ad, this ad right here. So we load the JavaScript for that ad. Now the thing is, if we click on load more content, we will make a request for the JavaScript for the load more content component. And then if we call that again, well, we don't make a separate JavaScript request. It's smart enough not to do that. And lastly, if we scroll down a bunch, we'll eventually start seeing images. And we can tell when we start receiving an image because we see this component again. And if we scroll down, well, there's that image right there. Awesome. So pretty standard stuff. Let's take a look at how that's implemented. So the first thing you'll see is that we have this ISO field right here. On the newsfeed item, which is a GraphQL type, let me zoom that in a bit more. The name of this field is newsfeed add or blog. There are these fields as add item. That's essentially equivalent to ... on add item. So underneath as add item, we select add item display wrapper. So if we go to add item display wrapper, you'll see that we have an add item display with loadable and lazy load artifact true. So in this case, we pass it to client side, use client side defer and pass it to a fragment reader. Okay, that's a little bit of boilerplate. Basically, doing this kind of thing is something that the compiler will eventually be able to handle for you. Okay, now if we remove this at loadable here, or let's do this. Well, we save it, the compiler is running in the background. What we're going to start seeing is that we have a type error here because add item display is not something you're allowed to pass to use client side defer, and instead what we can do is just return data.add item display. So now if we do this, well, we also need to pass on visible and index, whatever. I really should have used a slightly easier example to show this off. We do this, okay. Now we go back here, we'll refresh, and well, as we scroll, notice we're not actually, we've shown the add, but we didn't make a follow-up request for the add JavaScript because it was included as part of the parent bundle. Okay, so let's talk about what actually happens when the Isograph compiler runs. So there's a query, let me see, it's an entry point on this page, yeah. There's a query.newsfeed entry point here that we're passing to use lazy reference. So if we go to newsfeed/entry point, maybe it's this one, you'll see that we have this net request that's actually created. So if we, for example, let me find advertiser, I don't know where that is. Advertiser. If we remove advertiser from this and stop using it, well, for one thing, we're going to start seeing a type error here because we're not getting it. We're not receiving it. And then inside of this entry point, well, advertiser used to be right here. Now it's gone. And that's great. That means we're always sending the right data to the backend. Okay, so where is this typing coming from? So obviously, this is just some ISO function. It takes an opaque string, like we're clearly not parsing it. Well, TypeScript's too dumb to understand this. So what actually happens? Well, we actually import that ISO function from this @ISO thing in our some sort of tsconfig maybe. We specify that @ISO is the specific generated file. So in this iso.ts file, what you'll see is that we have overloads for this ISO function. If it starts with this string, I mean that's all that this matches white space and string is, you don't really have to worry about it too much. Well then, the type of that ISO function is this thing, and in particular, its first parameter has this type. So we go here, well, we see that the first parameter has an add item display, which is this add item display output type, which is a functional component that takes some sort of parameters, whatever. It like builds out a bunch of files, and as a result, when you use that ISO function, you immediately get everything that you need, like I don't know, type errors if you're making a mistake. Okay, so taking a step back, like what exactly is the big picture here? We generate exactly the query that we need. Every field includes its own data. We don't need to pass down anything. And then behind the scenes, Isograph will use these generated files to pass that data to the function that you defined, and to the outside world, it looks like we just received an add item display. But you know what? Every single add item display here, it's actually a unique component because it needs to know which data does it close over. So it's doing a lot of stuff here. It also does not like hot module reloading. So another thing that we can take a look at here is if we take a look at the components here, component tree, what you'll see is that all of these Isograph components, like this query newsfeed, this newsfeed adder blog, whatever, they're actual components, like in the literal React component sense. Okay, so big picture is this. We generate a query for an entire page. That query is sort of like the state of the entire page. And within that, like all of these subqueries, they really shouldn't be separate queries that have no known connection to the parent. So if you have two nested lazy load queries, well, that's a problem because now the nested lazy load query, it can't exclude the fields that were part of that parent query. You know, they really should have some sort of connection from like, we're on this page to like everything that's needed. So all of that can coalesce upward. And then this @loadable annotation, it allows us to essentially like carve out sections of this tree saying like, okay, everything underneath this, this add item or whatever, right? Carve it off, make it a separate network request. Okay, are we doing pagination? Well, we're carving that off into separate network requests that we keep on making over and over and sort of concatenating them in you know, components state land. And that has a lot of advantages. Like right now, we're not, these subqueries, they contain all the fields that the parent needs. But in the long run, that's not gonna be the case. Yeah, okay, so let's get back to the presentation. That's what I wanted to show off. So let's talk about the future of Isograph. So there's a lot. There's a long feature backlog, a lot of stuff that needs to happen. Like right now, I only showed off client fields. Client fields are essentially like a function from some graph data to an arbitrary value. But like there's another missing primitive, which is client pointers. So a function from some graph data to another ID, off of which you can select whatever fields you want. So you might have like a best friend on a user that's defined locally. There's going to be a VS Code extension that we want to ship. The compiler is currently written as a batch compiler, so we want to rewrite it as an incremental compiler to try to like get the absolute best performance we can get. Right now, Isograph generates GraphQL queries. It is tied to React and it's in JavaScript. None of that matters. The generated files, they're essentially JSON objects that import some function that you defined. That can be in Objective-C, that can be in Kotlin, whatever. The reading section can work with Angular, whatever. And the queries that we send out, they don't have to be GraphQL queries. They can be SQL queries. They can be persistent queries. It doesn't really matter. And lastly, all of these fields, well, they're currently executing on the front end. So that add item display thing, that happened on the front end. But like if you have something that lives in front of your GraphQL schema, or in front of your GraphQL server that takes these and transforms them, well, that starts to make a lot of sense, especially in the multi-platform world. You might define some sort of like best friend name client field in JavaScript, and your Kotlin app could just start selecting that field and get the serialized version sent down to the front end. Okay. And lastly, like finer control over selections. So right now, all of these fields that you saw, they have to be present for that client field to be rendered, but you might have a situation where, hey, you don't care necessarily whether that field is, you can handle a field being missing. Right now, that's not doable in Isograph, but I want to provide some sort of syntax support for that. Okay, that being said, I have an absolutely stunning, amazing update. Just this morning, on the train, on the Caltrain up here, just for you all, we released Isograph v3.0. This is the biggest release since v2.0.20. And oh boy, is it chock full of amazing features. There's connection spec pagination. There's massively improved docs. There's on-completed and on-error callbacks for network requests. There are fetch policies. There's support for Windows. We lifted the requirement that IDs are globally unique. There's support for refining to concrete types, those as add item fields that we saw. There's support for GraphQL unions. There's compiler watch mode performance improvements, it's like a 3x improvement. There's improved component prop types. There are CLI commands to generate the Isograph config. There's additional validations, like that there are no undefined variables. There's a bunch of bug fixes. We cut down on re-renders. I didn't even talk about how we don't re-render anything unless something changes. But we cut down on re-renders due to reusing part of the old value. And in particular, we use the reader AST to make comparing two different objects super, super efficient, something that, to my knowledge, is not done in any other framework. Just an absolutely massive, massive release. I had to print it out on a list right here just to make sure I didn't miss any of the parts, because I wouldn't have remembered that. But more importantly, then there being so many damn improvements, I'm just extremely happy that there are now 3 more core contributors to Isograph. Patrick Vawach, Vadim Nevsiv, and Lane Sawyer, all without whom this release could never have happened. So in addition, there's just so many more people now hanging out in our Discord, trying it out, poking holes, asking questions. And yeah, there are issues, but so far, none that call into question the fundamental feasibility of the project. So if you're tired of writing boilerplate, if you think that maintaining invariants isn't the highest and best use of your time, if you want to spend less time futzing and more time building, then I want you to contribute. Whether you want support, whether you want complete freedom, I can find a way to make it work for you. This is a project that's pushing the boundaries of the app creation developer experience, and there's still fundamental building blocks that are left to be built. So come help out. Or otherwise, give Isograph a try. Kick the tires, let me know what's confusing about the docs, or what missing features or blockers for you. And with that, I'll take questions.
How, with selections, because you don't declare any interface types,
Yeah.
how do you resolve that?
What you mean in terms of, what do you mean by that?
So, is the first word the type?
Add item here is the type, yes.
Or newsfeed item?
Oh, so okay, so this is the type. This is the parent type, the GraphQL parent type. This is the name of the field.
Right.
Yeah, an at component is just like, doesn't really matter what it is.
And so that could be a concrete type or an interface?
Yes, exactly. So you can, in fact, so this is an interface here. Newsfeed item is an interface, but this add item, this is a concrete type.
Yep.
Yeah, and it could also be a union, in which case the only fields on it will be the ones that refine to a concrete type, and so on and so forth.
So as add item is like a special isograph, like the as previous?
Yes, yeah.
And that's something that sort of spreads on the parent type.
Exactly.
Under the hood.
Exactly. It generates this. Yeah.
And you didn't talk about mutations much, but I imagine mutations are defined in terms of interface types and IDs.
Yeah, actually, so let me show you. Mutations are kind of an interesting thing. So on the one hand, like queries and mutations, they're just network requests. So if you want to use something like use lazy reference, or in this case, use imperative reference, which will issue a network request in response to like a user action, well, you can use it with a mutation, you can use it with a query, it doesn't really matter. So on the one hand, it's really easy to like just kick off mutations however you want them. On the other hand, there's also something that Isograph does that's quite special, which is this. So if we go here, where I don't want this sidebar anymore. If we take a look at this dropdown issues a mutation. So new best friend is Henry, okay? So the way this works right now is if we look for set best, I think it's set best friend, yeah. Okay, there's this set best friend field here. And this is read out as a function. And you can think of it as a loadable field where we have to unify the concepts a little bit. But like essentially it's a function that when called will make a network request to issue that mutation. So inside of the schema extension, what we're doing is we're on the mutation type, re-exposing the set pet best friend field on the whatever's that pet. So in this case, it's a pet type. Like on the pet object, there's a field called set best friend that, when called, will issue this mutation. And we remap these fields. So the pet's ID becomes the ID parameter of that mutation. Or in this case, like the ID field becomes a check-in ID, or the ID field becomes a input.id thing.
And those parts, they're parts from query?
So this is, so from the mutation, there's a field called set pet tagline.
Yep.
And then this map, this goes from the pet. This is a path from the pet.
Yep.
And the destination is the parameters that mutation field, or like the parameters the mutation field takes.
And what does path pet do?
So the pet tagline, so schema.graphql, the pet version, set pet best friend returns a set pet best friend response, and that has a pet. So it's this path right here. So you could do pet dot whatever if you wanted to. Maybe you can do that right now. You will eventually be able to, if it's not possible now.
And do you have like a normalized store?
Yes. Yeah. So here, what we can do, we're just getting a whole bunch of logs here. So if we go back to this, what you'll see is that there is this after normalization message that we received with the state of the store. The store is normalized first by type name and then by ID underneath that. So pet, da 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 da. So this is the change that caused us to. Sorry, that's like not really visible. So this is the change that caused us to not require IDs to be globally unique. And yeah, it's basically it's a. I mean, it is a normalized store.
But the IDs need to be unique to
Within the type name. Yeah. And okay, so the nice part about this, right, is that this set best friend function that you can read off of this field, right? Well, it's a mutation. And when we actually make this network request, right?
What happens when you've got like a naming collision between a mutation name that's global and like a type, like a field on the type? I know that's an esoteric.
What happens when there's what?
There's like a naming collision between a mutation and a field on the type. But
Oh,
I
it'll
guess
fail
you
to
map-
compile.
You,
It-
ma-
yeah.
you map it with schema extensions.
Yeah, it'll fail to compile.
Right.
Yeah. So in this case, so the thing that I was going to get at is that the network request selects the correct fields off of this pen. And if we go back to this, it doesn't actually select, you don't select those yourselves in the mutation, right? And the reason it knows to do that is because, well, on this pet in that entry point, at that location, we have these fields selected here. So it's going to select potential new best friends, et cetera, as a response to this. So that's overfetching because obviously the pet's name doesn't change when you change the best friend. So we need to add something to the mutation, the expose as directive, that will let you say like, oh, in response to the set best friend mutation, like only the best friend and the potential best friends will change.
How do you handle like action at a distance? Like you've got some graph, say you've got like the message list chat drop down.
Yeah.
And then you've got like a follow button, and that'll bump them in the chat list.
Yeah.
But you're in the scope of like the profile page.
Yeah.
How do you update the chat list? Is that like a side effect thing that you need to write in? Or?
No. So it's the same model as relay. So like if a record in the store changes, and a fragment is reading that record, then that fragment will re-render.
And how do you make sure the mutation selects all the data, or does it just select all the data that the app depends on?
It will select all the data in that entry point. So if there's two entry points that refer to the same object, that reach the same object, then you can make a mutation and have missing fields in that other one.
Right.
So currently what happens with those missing fields is that this component will just start suspending forever, which is not ideal.
No.
So what we want to do is essentially allow it so that if you were to start suspending, you go find the nearest entry point or the nearest like refetchable field or whatever and reissue that query. That's the idea that I have, but like I'm thinking that basically that last thing on the to-do list was on the backlog was that I wanted to provide more precise control over what actually happens in situations like this. Because sometimes you don't want that. Sometimes you want stale data. Sometimes you just want missing data. But yeah, all of this stuff needs to be like, you need to have control of it as a user. And the problem is that like the simple thing is probably the right thing in 99% of cases. And it's kind of like you have to figure out what's the right syntax to add the additional control without ruining the developer experience of the simple, I just want the data if it's present and not error. But generally I want to refetch if due to a mutation change, stuff starts to be missing. Yeah. And then you also need to be able to tag certain fields, like the newsfeed. It isn't something that you want to ever refetch, right? So the newsfeed needs to be known as like volatile or something like that, but everything else is like refetchable. Yeah. So that's basically what I want in situations like that. And then there's, yeah. But yeah, that's the idea.
Do you have any real-time APIs?
No.
No.
closest thing we have is a live query that just like keeps pinging the GitHub API.
Yeah. I guess you could have like a client, when you get client fields built, you can bind to like a real-time API.
Yeah. So the idea I have is this: so that like backend thing that I talked about. The server that lives on the backend, it's not just like, oh, you define like a pet best friend name or whatever, like, you know, client field, okay, like, so send down the serialized version of that. It's not just like React server components. The other thing that I want is like, if you execute a query, if you're on a given page with an entry point, we know all the fields that you're looking at. We know the state of that entry point, right? So given those, I want to have some sort of something that lives on the back end, that lives in front of your GraphQL server, that just sets up subscriptions to all the fields that are part of that entry point. So essentially you have some session state that says like, Robert is looking at page 1, 2, 3 with these variables, therefore we're pushing down all the updates in real time. Obviously that's not going to work for every single app. Like if a user is worth pennies and you have a trillion of them, like, well then that's probably doesn't make sense. But if it's the Bloomberg terminal, well then yeah, probably everyone's paying 30 grand a year, so like, you know, sure, send down some data to the front end and